All right, guys, I wanted to do this quick video, hopefully quick, but probably not too quick, over learning target 6 since we did not have class time to go over it. I did send you guys those videos to watch during class time, so this should be okay. It shouldn't be brand new if you watch those, but I did want to talk some things through and maybe do some examples since we missed that in class. So this is learning target 6. I can understand piecewise functions and their operations. So we're going to evaluate these functions, graph these functions, read a graph of these functions. Everything we can do with a normal function, we're going to do specifically with piecewise functions. Now, we're mainly going to focus on linear piecewise functions because we're comfortable and familiar with linear functions, but this is something once you get to calculus, you'll have all types of functions mixed in. Okay? So, apparently it's pretty tricky to go to the next slide. Let me move me so I can do it down here. This is good. I'm trying a new way of filming videos, so sorry for the any confusion that I go through. This is a piecewise function. So what is a piecewise function? Well, a piecewise function, it's what it looks like. It's a function made of pieces. Okay, so if we look at this graph, this is a piecewise function. We know that it's a function because if you do the vertical line test on this, you will notice that it passes the vertical line test. One place where maybe it doesn't, well, it does, but you might be confused, is where we've got overlap, right? Like right here. It looks like maybe it doesn't pass the vertical line test, but notice that one of the circles is open and one is filled in. So it actually does pass the vertical line test at all points in this graph, okay? But it doesn't look like, it's not like a line that's just broken up, right? It's not like, oh, here's a piece, here's a piece, here's a piece, right? It's different types of functions. So that's where the piecewise comes in. Each piece of this graph is represented by a different function, a different equation. Okay, so a piecewise function will have the same number of equations as it does pieces. So this has 4 pieces on the graph. We have 4 different equations. Now, you guys don't know these equations. Well, you know 2 of them. You don't know 2 of them. But they are just functions. They work. The important thing to look at is that each equation represents a piece of the graph. And it represents it on a different domain. So that's what these restrictions over here are. Let me change the color. These are all my equations that represent the graph. That's the function. Right here, right there, is where the function is. So x plus 5 is when x is less than -8. So if we look at our graph, it's when x is less than -8. Uh-oh. I don't know what my pen was doing there, but it's less than -8. It's all the way to -infinity. Okay, that's the first piece of the function. For the second piece of the function, it's sine, which you won't know what that is till you're at the end of trig, but this sine function is from -8 to -2. So notice it starts at -8 and it stops at -2, and it's open circles. So we had a closed circle on -8 for the first function because it's included in the function. And we had an open circle on -8 for the second function because -8 isn't in its domain. It's not actually part of the function. Really, really close to -8 is, so like -7.999. So we represent it as -8 with an open circle, okay? Then the next part of our graph is a quadratic. It's just x squared from -1 to 3. Notice the -1 is included in the domain because it's or equal to, so that's a filled in circle. The 3 is not. Notice here we jump. We have a gap. This function is not defined from -2 to -1. Right? There's no part of the graph there. That's okay. It's discontinuous, right? It's jumping. It's not a continuous function. But that's okay. It still passes the vertical line test. Okay, and then last but not least, We have log of x, which is another function you won't see how to graph until trig, but it's for x greater than or equal to 3. So we include the 3 by doing a closed circle. Okay? And then this is kind of what I said earlier. Ooh, what's this pointer thing? Ooh, that's fun. I'm going to use that. Piecewise functions have the domain restriction. So that's what I was talking about. This is where in the graph it is. Okay? So evaluating from a graph. We are going to evaluate from graphs, we're going to evaluate from functions, and we're going to graph functions. But just like you can pick a point off of any graph, you can also pick points off of piecewise graphs. Okay, so if you're given the graph and you want to find a value, you go to the x and find the y. Right? When we talk about values in terms of functions, value is the y coordinate. It's asking what output. You know, the value at x equals 3 is whatever the output is when the input is 3. Okay? So what we would do, we'll do an example in a second. So you pick the x, I say like x equals, this pointer thing is very fun, but let me actually get a pen so I can draw. If I said like x negative 4, right, I would go to negative 4, which is 1, 2, 3, 4, which is here. And then I'd go up till I hit the function, and that, whatever y value that is my output. So basically I'm looking for the ordered pair. I have the x, I'm looking for the y. Okay, so if I look on this graph here, it'll let me switch, find f of negative 1. So what I'll do is I will go to negative 1. I'll go to negative 1 on the x, because remember, it's f of x, so negative 1 is the input, it's the x. Negative 1, and then I'll go up till I hit my function, and it's right there, okay? So I've got x equals negative 1. I hit the function, okay, and it's a little off. I would say that's like half, not 1, but you know, whatever, we'll pretend. It's a closed circle, which means it actually is a point. So we're going to call it negative 1, 1. Maybe we just need to make that circle a little bigger to show that it's really at 1. Just make a big circle. It's at 1. But hopefully you can, get the idea there that because it's, we go horizontally along the x to that point. So f of negative 1 means x equals negative 1. So I find x equals negative 1 on the x-axis, and then I go up or down until I'm on the function. So the point here would be negative 1. I'm going to say 1/2, but I'll let it slide. Okay, that's the value of the function. The value is the y coordinate. Okay, so this is something that we would do in class, so let's do it now. This would be like, try this on your own. We're going to try it together. So if I look at this, right, use the graph to evaluate each of the following. Check your answers on the next slide, whatever. F of negative 5. So what I do is I go on my x's until I get negative 5. And then I go vertically. I'm going to go up because I have eyes and I can see that the function's above it. I go up until I hit my function. And then I go over to the y-axis and I can see, oh, it's at 2. So f of negative 5 equals 2. Okay, that would be the ordered pair. And I don't know why this disappears. Whatever system I'm using, I guess it doesn't stay, but that's okay because you can pause and rewind. This would be the ordered pair negative 5, 2. Okay, so you may have to pause these because it seems to just disappear, but you get the idea, right? We go up at negative 5 over to 2. Well, that was, that did not work. There we go. We go over to 2. Okay, f of negative 2, I'll go over to negative 2. I go all the way up, I don't hit my function. I go all the way down, I don't hit my function. So this is undefined. That's how we would write that. We would say undefined or UND. Sometimes people put UDF. The common one is UND. So it's undefined. There's no output for the input -2. Okay, f of 0, we don't go anywhere on the x-axis. We just go up, we hit 1. So f of 0 would be 1. That means that it's the ordered pair 0, 1, right? We're looking, when it says f of 0, it's saying when the input is 0, what's the output? The output's 1. When I go to 2, I go up, and that's going to be 4. Okay? Let's check our answers, see if we did this right. Fingers crossed. Looks good. Okay? All right, let's keep moving on. So from a graph, it's not too tricky because we can visually see, oh, let me go to x equals 3. Oh, that's the function it's with. But when it's a piecewise function and it's given to you in function form like it is here, it's a little trickier because we can't just look on our graph to figure out which piece of the graph it is. We have to use these, we have to use these domain restrictions to find it. So if I wanted to evaluate f of -2, okay, normally if it was just like f of x equals 2x plus 3, I would plug -2 in and solve it, right? But here we have a problem because this function is cut into pieces. So when x is less than 0, the function is 2x plus 3. But when x is greater than or equal to 1, the function is 2 to the x. So when asked to evaluate f of -2, we have to notice that, okay, x equals -2, right? That's what x is. So I need to figure out which inequality, and sometimes there's more than 2. There could be infinite number. Which inequality -2 falls into, right? -2 is less than 0, right? It's not greater than 1. -2 is less than 0. So that means when it says f of -2 for this function, we're not plugging into both. We're plugging into the first function because this function is defined for x less than 0, okay? So we don't plug it into both. We don't just randomly pick one. We plug it into the one that its domain falls into. And -2 is less than 0. So there you go. You plug it in, you ignore the other part, and you solve. So f of -2 would be -1. Okay? For this one, so this is the same function, this is the same f of x. They want us to find f of 0. Again, what we do is we look at the function and the domain. We're looking at 2x plus 3 is less than 0, 2 to the x, x is greater than or equal to 1. We want to figure out, okay, x is 0, where does it fall? Well, if we look at this, it's actually it doesn't fall in either of those, right? If it was x is less than or equal to 0, we'd have a conversation, right? It'd be in the first one. But 0 is not less than 0, and 0 is also not greater than 1. So it's not defined on this function. We can't input it anywhere. It's not in the domain. So this one, we're just done. It's undefined. Okay? So that's like a special case that we could see. All right, so let's try some. I don't know if we'll do all of these. We'll do some. Okay, so f of 8. That means, if I have f of 8, that means that x equals 8. Right? F of 8 means that x equals 8. So I need to go through each of my domains and figure out where it falls. Before I even think about plugging it into one of these, I need to know where it falls. So I ask myself, is 8 less than or equal to -4? No. Is 8 between -4 and 3? No. Is 8 greater than 5? Yeah, it is, right? So that's how I know when I'm looking for f of 8, I'm plugging in to this function because x is 8 and 8 is greater than 5. So f of 8, that's a very bad 8, is going to be 8 plus 2, which is 10. So f of 8 is 10, also a terrible 10. Okay? For f of negative 5, I do the same thing. I say, okay, let me check. You have to check the domains first before you can plug anything in. So I go from top to bottom. I guess you could go bottom to top, doesn't matter. I first check, is negative 5 less than or equal to 4? Negative 4. Yeah, it is. So we're good, we're done. We know that the function we're plugging this guy into is the top one. Okay, so f of negative 5 is 3 times negative 5 squared, right? I'm just inputting negative 5 into that function. Well, remember, and this is something some of you guys messed up on the quiz, negative 5, and of course it disappeared, negative 5 squared is positive 25. Right? I don't know where you crazies got negative 25. Well, I do. You typed it into your calculator wrong. But a negative number squared, well, that's supposed to be 75. We'll just wait for it to disappear. A negative squared is always a positive. Okay? So f of negative 5 is 75, if I could write it. There we go. All right, f of 0. I need to see where, if anywhere, 0 is defined. So I'll start by evaluate f of 0. I check the first one. Is 0 less than or equal to negative 4? No. And maybe if you're struggling with this, maybe on your paper you draw a number line and you say, okay, you know, from negative 4 this way, it's this function. From here to here, it's this function. From here to here, it's this function. You can set it up differently. I like to just check my numbers, right? Is 0 between negative 4 and 3? Yes, it is. So I know that my function is 11, which is like, huh? How is my function a number, right? F of x equals 11. What does that mean? There's nowhere to input my x. And that's exactly what it means. It means no matter what your x value is, it's always 0. Okay? All right. These last 3, maybe give a try on your own. Well, we'll see. We'll see the answers. So maybe pause. Try those on your own. Pause. Okay, you're back. Let's see what the answers are. Okay? So good on the first ones. Something tricky with f of negative 4 is you plug it in to the top function, right? Negative 4 less than or equal to negative 4? Yes. Is negative 4 between negative 4 and 3? No. For 3. F of 3, you plug it into the middle function because it's less than or equal to 3. 3 is less than or equal to 3. And then for the last one, it's undefined. Because notice, 5, it's not less than or equal to 4, or negative 4. 5, it's not between negative 4 and 3. 5, it's not greater than 5. There's no piece that this fits into. Okay? So it's undefined. All right, so here's kind of a summary of what we've done so far. Piecewise functions are a bunch of different functions grouped in different domains. Remember, domains is x values, so different x values. Okay? You can evaluate a piecewise function on a graph by knowing what the input is, going to that on the x-axis, then going up or down till you hit the function, and then going to the y-axis, and that's your value, right? We call that a value. Okay? We can evaluate equations without a graph, if it just says like f of 2, by looking at which domain it falls into. Okay, and then just plugging it into that equation. And then lastly, if it doesn't fall in the domain, or it doesn't hit anything on the graph, that means it's not defined at that point. It means that it's undefined. That's what we call it. Okay, so that's what you'll write on your paper for those type of values, is undefined. Okay, so the next thing we're going to do is we are going to practice graphing these. Now, I think I'm going to make a separate video for this because I found this site that I'm using right now to screen record, since it doesn't since what I write just automatically disappears within like 30 seconds. Probably not a great system to use for this. So I'm going to make this a separate video. So yeah, thanks for watching, I guess.